Once upon a time, there was a world where reality was entirely constructed out of first-order predicate calculus, or FOPC. In this world, everything was made up of words and logic. The people in the world were called logicians. They were able to use FOPC to cast spells and perform magic. The most powerful logicians were called wizards. They could use FOPC to create and control reality itself. One day, a young logician named Alice discovered a new and powerful spell. She called it the FOPC spell. This spell allowed her to manipulate the fabric of reality itself. Alice quickly became one of the most powerful wizards in the world. She used her powers to help people and to make the world a better place. One day, Alice heard about a dark wizard named Bob who was using his powers for evil. Bob was using FOPC to create monsters and destroy villages. Alice knew that she had to stop Bob. She used her FOPC spell to create a powerful army of logic beings. She then led her army into battle against Bob. The battle was long and fierce, but in the end, Alice and her army were victorious. Bob was defeated, and his evil plans were thwarted. Alice continued to use her powers for good. She became known as the greatest wizard who ever lived, and she used her FOPC spell to create a world where everyone could live in peace and harmony. Here's an example of how a logician in this world could cast a spell. The logician would first need to write down the FOPC code for the spell. For example, if the logician wanted to cast a spell to create a ball of fire, they might write the following code, which would be create object fireball. Once the logician has written down the code, they would then need to speak it aloud. As they speak, the logician would need to concentrate on the desired outcome of the spell. In this case of the fireball spell, the logician would need to concentrate on the image of a ball of fire appearing in their hand. If the logician is successful, then the fireball will appear in their hands. The logician can then throw the fireball at their target, or they can use it to light a fire. The power of a logician's spells is limited by their knowledge of FOPC and their ability to concentrate. The more knowledgeable and focused a logician is, the more powerful their spells will be. The fictional world of FOPC is a world where logic and magic are one and the same. It's a world where the power of words can be used to create and control reality itself. This is just a short story, but it gives you a glimpse of what a world entirely constructed out of FOPC might look like. In such a world, the most powerful people would be those who would create the best spells based on logic. These spells could be used to do anything from creating new objects to controlling the minds of others. It's an interesting thought experiment to imagine what such a world would be like. Would it be a utopia where everyone is happy and healthy, or would it be a dystopia where the powerful use their magic to oppress the weak? I guess it would all depend on the people who lived in that world. Imagine that FOPC is a language for describing the world around us. It's a language that allows us to talk about objects, properties, and relationships between objects. For example, we can use FOPC to say that all birds fly. In FOPC, we would write this as essentially all birds can fly. This means that for all objects X, if X is a bird, then X can fly. We can also use FOPC to describe more complex relationships between objects. For example, we can use FOPC to say that John is a parent of Alice. In FOPC, we would simply write this as is parent, and then in the brackets we would put John and Alice. This means that the object John is the parent of the object Alice. FOPC is a powerful language because it allows us to reason about the world around us. For example, if we know that all birds fly and that John is a bird, then we can reason that John can fly. FOPC can be applied to a wide range of things. It can be used to describe mathematical knowledge, natural language knowledge, and common sense knowledge. It can also be used to develop artificial intelligence systems, natural language processing systems, and software verification systems. Here's a simple metaphor to help you understand FOPC. Imagine that you have a box of toys. You want to describe the toys in the box to your friend, but you don't want to list each toy individually. You want to describe the toys in a way that is general and reusable. You could use FOPC to describe the toys in the box. For example, you could say that all toys, if it's a toy, has a color. This means that for all objects X, if X is a toy, then X has a color. You could also say that if the object is a toy, then it's red. This means that there exists an object X that is both a toy and red. Using FOPC, you can describe the toys in the box in a way that is general and reusable. You can also reason about the toys in the box. For example, if you know that all toys have a color and there exists a red toy, then you can reason that there exists a red toy in the box. So at this point, why exactly are we talking about this and why have I gone over this? So the big thing to me that this is applicable for is when it comes to artificial intelligence models, and especially natural language processing models, as this gives us a unique mathematical framework to utilize with large language models. Essentially, it gives us a framework to frame anything that we can think of within logical terms in actual definition. We can take these concepts and actually give them a framing. We can have a frame for all. We can have a frame for the predicate and for the subject. Essentially, it's taking the elements of language and giving them a mathematical formula and way to use that math behind it. So for someone like me personally, this is just off the charts useful. Like my personal mathematical background would be I've always looked at math kind of unique. Like I think that we teach math wrong. I went like algebra, geometry, calculus, trigonometry, etc. Right, and then so for me personally, the one I struggled the most with was algebra. Like I could not grasp algebra. Like it did not make sense to me, and it didn't make sense to me because of that combining words or like letters that aren't words into the mathematical equations. But then once we got into like geometry, trigonometry, calculus especially, like it clicked for me immediately, right? Like being able to actually utilize and bring in like actual words, not just like x meaning like x, and this nebulous x doesn't actually have an actual concept or a grounding in actual language. Like I don't know, for me and the way that my brain works, I interpret language and I understand language and the backgrounds of that very well. Like just I don't know, but I was like when it comes to nebulous, like more nebulous math, I don't understand. Like I had again like algebra and geometry were like the two comparisons for me growing up. I took algebra twice, I couldn't pass it, and then geometry I aced it without even trying. Like it wasn't a contest. Then we tried trigonometry, right? Like trigonometry, it just came easy to me. Like I understand this. I understand these concepts and how they work. I don't even like need to think about them offhand. It's like kind of how just my brain gravitates towards these concepts, and then so within the first time that I saw first order calculus, I can't get over essentially how this works and what you can do with first order predicate calculus. Like to me, this overall concept is an amazing concept. I can't wait to explore it further, but I want to make a video on this concept and just highlight kind of like the significance and the overall usefulness of this mathematical framework that you can utilize. You can utilize the first order predicate calculus to prove Pythagorean theorem, for example. So it's useful in real world instances, but then amazingly useful when it comes to natural language processing, right? Like if you have a LLM model, for example, that doesn't necessarily know or have the same knowledge that you would expect, let's say, out of an adult human or even like a developing human in some instances, to be able to give them that actual framework and that actual like logical grounding using a mathematical equation, like using mathematical concepts is huge to me. So FOPC is, to me, kind of just like this groundbreaking thing that I have realized that exists, and I cannot, I am beyond grateful that this concept exists. This makes intuitive sense to me as to exactly how you can utilize calculus in this way, and like how you can utilize language in this way, and break it down into like mathematical concepts that I could actually use in lots of different ways. So if you like this type of video, please like and subscribe. Thank you very much.